Right, so this is just a video and help you get through exercise 12.2 of complex numbers. So the first thing up is an invention by a guy called Argand, who invented the Argand diagram. He came up with this idea of representing complex number on essentially what's your same as what you've done in coordinate geometry. So we have two axes. The real axis, you can write that as RE. When I cross it out, there's going to be highlighted, and IM to represent the imaginary axis. So for example, 3 plus 2i out along the x-axis, or sorry, the horizontal axis, the real axis for 3, and then up 2 squares to make that 3 plus 2i. Minus 4 plus 3i, minus 2 minus 3i, the exact same way as you would graph coordinates on a coordinate plane. And then the next thing you meet in this exercise is a thing called the modulus of a complex number. Now the formulas here, it's important to realize that you don't put bi into the formula, you put the value for b only in. So for example, I thought I had an example here somewhere, but obviously I don't. So you just put in, let's say 3 plus 2i. The modulus will be a is equal to 3, that's 3 squared. B is equal to 4. B is equal to 2, sorry, that's 2 squared. So you get 3 squared plus 2 squared, that's 9 plus 4. The modulus of that complex number there is the square root of 13. The answer will always be positive. What the modulus actually represents on the Argand diagram is the distance of a number from the origin. So in this case here, the modulus there is equal to, well, same as the example down here, square root of 13. It's basically Pythagoras' theorem. How far are you away from the origin? For this one here, the modulus is going to be 5 because it's 4 squared plus 3 squared. And here's maybe a sort of fancier example from the textbook there. Solution to question 8 in exercise 12.2. The question was, go and find it here. Let's go to question 8 here. So you're asked to work out a half of 6 minus 8i is equal to 4 plus ki. Find two possible values of k. So if you get the modulus of this bit here, that is 6 minus 8i, that's going to be 10. So half of 10 is 5. This side over here becomes the square root of 4 squared plus k squared. And let's go back here and have a look at what they had in the solutions. So you have a half of 10 is equal to the square root of 16 plus k squared. Break that down to 5, square both sides, work out k squared equals 9. K is equal to plus or minus 3, and that's pretty much as hard as it gets. So I hope you don't have too much problems getting through that exercise. I don't see anything else there of any major excitement. You know, maybe the last few bits there, maybe the Z1, Z2 part is not covered until later in the textbook, so that part there might cause you a problem, but apart from that, it's a nice exercise. Okay.